Oh, congratulations.
Thank you.
And let's see, you have some words also about your
Yes,
research.
Sorry, I'm gonna present in English. I am not
I
quite
think that's
fluent in
fine.
Swedish. Okay.
Just put it there, maybe hold it. Yeah.
Okay. So I have some slides, but I'm gonna go through them fast. So my name is Eleni, and thank you for the honor of being here. My project is regarding neonatal brain injury, and specifically I'm focusing on T-cell immunomodulation during neonatal brain injury. And I'm working with hypoxic ischemic encephalopathy, or HIE as I'm gonna call it from now on, that has incidence of 1.5 per 1,000 live births in developed countries. And it's the 5th largest cause of death in children below 5 years old. And survivors may develop neurological or developmental problems such as cerebral palsy and learning difficulties. HIE is characterized by hypoxia, which is the diminished oxygen in the blood supply, and ischemia, which is the low blood flow to the main parenchyma. And so far, the most common therapeutic strategy is hypothermia, which is basically putting the babies at 33.5 degrees for 72 hours. However, it has to be performed within 6 hours from birth, and it's only effective in a high resource setting. And so far, we don't have any treatment methods for later stages of the HIE, which is something that I am working at. So there has been several studies performed from our group regarding systemic inflammation during HIE, and they have found that it actually aggravates the brain lesions. So our group was also the first one that found long-lasting inflammation after hypoxic ischemia in newborn mice, and they found that there was a peak in the T cells in the brain during 3 to 5 months, and the T cells stayed there up to 7 months after the insult. However, we don't know exactly where these T cells are, which types of T cells are actually involved in the HI insult, and how and where these lymphocytes are distributed in the brain. So my first 2 research aims regarding this is to work with mice and to actually find the T cell activation pattern in the mouse brain, spleen, and blood at 3 to 5 months after HIE, and to study the effects of immunomodulatory compounds such as fingolimod or natalizumab, which are compounds that have been suggested for MS, for treatment of MS and stroke, on T cell activation, injury size, and behavioral outcomes after HIE. So for that purpose, I'm going to be using mice at postnatal day 10, and we are going to perform the Rice-Vanucci model. And after 3 to 5 months, that is the peak of the T cells that we saw infiltrating the brain in the long-lasting stage of the injury, we are going to characterize the temporal and regional pattern of T cells in the brain, spleen, and blood, which is something that I'm working now. And we are trying to do that by using flow cytometry and single-cell transcriptomics analysis. And we are going to also treat with different immunomodulatory compounds, as I mentioned, and then we are going to perform behavioral studies and histological evaluation. Now, regarding the clinical studies in HIE, there is almost no data on T cells after neonatal HIE in humans. However, there has been a case study involving 4 babies with neonatal stroke that they have shown that there is a different pattern, most probably than in mice. So there is a pro-inflammatory profile that then changes and the inflammation decreases. So we want to check if there is actually a different response in humans than in mice. And for this purpose, my last research aim will be to characterize the T cells in the peripheral blood of infants with and without neonatal brain injury and relate to outcomes. So for this purpose, we are going to use blood samples taken from babies with hypoxic ischemia at 7 days, 3 months, and 6 to 12 months after the insult. And we are going to compare the data that we will find with FACS with healthy babies of the same time points. And we also have data in neurological, motor, cognitive, and language development from the neonatal registry at 3 months, 6 to 12 months, and 24 months, and we are going to correlate the FACS data with the functional outcomes. So yeah, that was it for me. Thank you very much.